This is a demonstration of some of the functions of Parallel Data Mover. It's not meant to show all of the functionality of the product, although PDM is an enterprise-wide managed data mover, which supports bidirectional movement between any two ZOS or LUW hosts. This demonstration focuses on options to move data from ZOS to Linux to specifically address the ease of using the product in providing all forms of ZOS data to other platforms for purposes such as data warehousing, business intelligence, and creation of AI data lakes. What you see in the picture here is the primary menu for the ISPF client. And it has basically provides a window into the subsystem. And these are the things you can do with the ISPF interface. Basically, it's for displaying and monitoring, but it does have the ability to move a file, and we're going to use it to do that. You would not use this for production kinds of applications. It would be just for an ad hoc movement of a file. So we're going to pick an option of copy, and we're going to name the file, which is this is about a just under 5 gig file. And since we're moving it from the local host, it says right here, omit host name and credentials, so we don't have to put it. Where we're going to move it is we're going to move it to a directory on another machine, on a Linux machine, and we're going to call it test.txt. Little typo there. All right. The host name is Sycamore, and we're going to use the root account. I'll put the password in for that. And now we have a choice of doing it streaming mode, which would be basically like binary, or C to do character conversion. So it's going to convert the file from its EBCDIC representation on ZOS to an ASCII. So this is a simple total file conversion. I hit C for character, and you see it's scheduled. So now let's get out of here, and I'll pick option 1, which allows me to monitor the transaction. So on this screen, you see the request number, who did it, the function, where it's going from, where it's going to, the number of megabytes that have been transferred, and the data rate. So if I hit enter, it updates the screen, and it's over. So now, if you want to go look at the transaction that we just ran, then we're going to pick option 9 here. And you see all the transactions that have run, and the most current one is at the top. You can change that order, but that's the way I chose to do it. And if you look at this screen, it gives you the request number, who requested it, what the function was, the status is complete, completion code, in this case 0, reason code 0, start time, stop time, number of bytes transferred in megabytes from host and to host. So if you want more detail about this, I can hit S, and it gives me a little more information about the transaction, and which includes the file names to and from. And down here, it tells us that it completed successfully because it interpreted the completion code and reason code. And if you want to look at more detail, and this is, I think, a really powerful part of the product, in that it maintains performance records even when the transaction's done. So we look at performance statistics, which is what this is for this particular transaction. It gives me a very accurate byte count, and it gives me the throughput numbers, and it gives me the number of IOs I did. But this is what's really amazing. You notice there was no time spent on general purpose processors. It all ran in a zip. So this 100% zip time. So it had no impact on anything going on in the mainframe. And the same statistics on the target system, although, of course, the statistics regarding the ZOS system are, I think, far more valuable to most people because those MIPS are far more expensive. So that basically is the completion, or is all I really want to talk about regarding that transfer. But I also want to show you that in the event that a transaction fails, like this one did, if you select that one, you get an English representation of why it failed, and it tells you that the file or directory on the target system doesn't exist. So the source file is not there, so you can easily fix it and move on. So besides just getting an extensive or providing an extensive list of completion codes, that we can also translate that into an English representation, so you know exactly what went wrong and you don't have to go look them up. And that's the conclusion of the ISPF demonstration. Now I'm going to demonstrate the use of the PDM, one of our clients on ZOS, to move data. So I've created a job that does that. This is a 3-step job. This deletes the data set. This step creates a file. It's a data generation program. It's not part of PDM. We wrote this program for testing purposes. And basically you tell it how much data you want to generate and what type. So we're going to generate a megabyte of data, and it's going to be character mode data. And then we're going to invoke the PDM XCLI in this job step right here. And it's going to copy a data set from DD, which is the same one we created up here, to an LUW system. So this shows you how simple the language is. It says copy from DD equals to file equals with a file name, where it's going to land, and the fact that it wants to do ASCII conversion, EBCDIC to ASCII conversion. And then the query detail gives us the results after the job runs. So I'm going to submit that job, and we go over here to a session with Sycamore, and we see that the LS that I did just before does not have that file there. But when I do an LS now, you see a new file called test1.txt, and I can cat test1.txt, and there you see it. It's just character data that got generated by that program. So let's go back and look at another way of doing this, which we're really excited about and all of our customers use. Here's a version that does exactly the same thing. So here's the generation program, but instead of landing it as a file first and then moving it, it generates the data directly onto the LUW system. And this uses PDM's SubSystem Interface. So there's the name we want to have, which is test 2. The other one we just did was test 1. And DMED is the name of the subsystem, the PDM subsystem, this particular copy of it. And I move using a profile. The profile just has credentials. It has user ID, password, and it also has the name of the system that I'm going to move this to. And data type tells me that I'm going to do EBCDIC to ASCII conversion on the data. So it should look exactly the same as the other. So if I run this job, and then I go over here and look and do another LS, you'll see that test2.txt is now here. And if I do a cat of test2.txt, it's exactly the same file. In this example, we show the ability to move a file directly to the cloud. Specifically, we're going to move it to a bucket on AWS. So this looks a lot like the job we ran before. We generate this data, and in this case, the XCLI is used to do it. And you'll see that really the only change we made was to use a bucket name. And by preceding the name of the file with S3 colon, it says this is going to an S3 object. And so there's the bucket name, and there's the file name, and there you go. So we're going to run this right now and go all the way to the cloud. And over here, you can see that I ran a list, just ran a list of the S3 using Amazon's command line interface. And you'll see that the only thing in there is something called test1.txt. If I run it again, you'll see, lo and behold, I put test 3, which is the job I just ran there. And if I want to display it, I can say, this is the way you have to do it, S3 CP copy, S3 PDM test and / test3.txt. And so you copy it to dash, go. So, as an alternative, I could do the same thing using the SSI again. And so you see for a dataset name, I picked test4.txt, and again, specify the bucket name. And if I run this, looks a whole lot like the one I ran before. And bingo, I go over here and I go do a list, and there it is. And if I want to copy it, let's just pick test4 here. And there it is. So I took a job as is, and all I did was code this, and I landed it directly in the cloud. This job could be anything. It could be a job that unloads a database. It could be a job that just run every day that does maybe a sort, and then the output of the sort you want to send somewhere. Well, instead of landing it as a file, then moving it, and then importing it into the cloud, it's a single step and it's there. Another powerful feature of PDM is its ability to dynamically on the fly format data per specifications that come from COBOL copybooks. And so we have an application that we give you that will convert a COBOL copybook library or a single copybook to JSON files that map the metadata. And so whenever you move a file that contains, that was created by COBOL, for example, you can supply this JSON file that maps the data, and we will do the formatting for you automatically and land the data in any number of formats that are importable into other databases and such. So this job in front of you is an example of something that does that. We have our own program that we wrote. This is a test program, and that program formats the data and writes it as if it, well, comes from a copybook. We dynamically generate the data, and we generate data that matches what the copybook says, and write it. So that program knows nothing about the SSI. All it does is write a sequential file. And so in this particular case, I'm using the SSI, and I'm specifying the file name. You notice I end it with .csv. That tells PDM that you want it to land as comma-separated values as far as when you use the metadata. So here we give it the same information, and in addition, we specify a format. And this file right here contains the JSON metadata mapping that we generated from the COBOL copybook. So when I send this job, we'll go over here again and look at an LS that I ran prior, and you'll see there's no such thing as test 5, but when I do another LS, there is a test5.csv. So let's go browse that, or do a cat. And there you'll see it's formatted. There's all kinds of different data types here, by the way. There's character fields, there are floating point, there are ones with picture clauses with a single decimal point, packed decimal. We did a pretty good range in this file of different things that might show up in a COBOL copybook. That was pretty simple. And again, the power of the SSI is that I could take the output of the COBOL program and land it somewhere other than as a sequential file in ZOS. Very easy. All I had to know was how to do this. There's no learning curve, almost no learning curve with this application, or for your systems people to be able to generate jobs that do this. Now I'm going to demonstrate a really easy way to load data directly into IBM's WatsonX .data database. Very simply by using the SSI and specifying that the Hive bucket name, and I'm sending a file there that's called test3.parquet, and it is again, going to use the profile and the formatting data, but this time it's just going to land directly into the database. So when I submit this job, and I go over here to, I'm logged into WatsonX.data, and I look at the history of what's happened, it is ingesting the data right now. And as soon as it's done, we'll look at it. Okay, it's done. So now we'll go back to home, and we'll go to the query workspace, and I've stored a query called my work. So now I'm going to run a select against it, and look, lo and behold, down here you see that all the data has been loaded and properly use the metadata to format the fields. Now that, I think, is impressive because of how easy it is to load bulk data. Very straightforward. It has to be the easiest way and the most efficient way to get it done. This could be any data source. Again, this program, all it does is generate random data. It could be any of your programs that land sequential files.